the stage is yours. So.
Yeah, thank you. Thank you so much. So starting this up, you should see my screen now, and I think you do, no? Okay, cool.
Yes.
Great. Okay, so I'm GNL Systems Integrator, Managed Service Provider. We work with a lot of partners. Some of them are in this call here already, and we work for a lot of different customers. And we build very bespoke media processing pipelines and manage them. And one part of our team has been working on live event streams. So we send them to live events from customers like parliaments or automotive car companies that need something for stakeholder conferences. And in many cases, they had been asking for sign language, and we don't have sign language interpreters at the company. And so we had to acquire them from the market, which was very expensive and scarce because there are not many enough. And so for a very long time, we looked into how can we use AI to add something that works. And I tried myself. I have a background in phonetics and linguistics as well. So I tried 2 or 3 years ago and thought, hey, well, the important part is getting the avatar right and making a human that can do sign language movements. But that's not the hard part. That's the easy part. The hard part is getting the grammar right and the translation and treating it as what it is, a language of its own with its own rules. And so that's the difficult part. So let me check where I can click here to the next slide. Why is that not working? Okay, so the problem is we have far more people who need sign language than we have interpreters who can serve. And in many countries, we have legal rights for deaf people so that they can have a translator or an interpreter when they go to the doctors or when they go to legal issues or to some institutions where they need a bidirectional translation. But there aren't many interpreters in each market here. And the problem then is that many of them are being used for broadcast, for one-to-many communication, where they are just translating something that is sent out, but not coming back information. So it's not a real translation by 2 directions. It's more like a broadcast that is translated also into sign language. And these figures here might be impressive. We had a call with a potential customer from India. They say they have 60 million sign language users in India, which is not a wonder because they have so many people living there. So they have a whole different order of magnitude of problems with that. So that was one of the motivations. The second motivation is that in many jurisdictions, it's not anymore optional to have sign language or to have accessibility at all. It's an obligation, and many companies come to us and say, okay, we have a duty to provide something here. Can't you help us in building that or in supporting us? So this is a very recent recording from the German sign language. So what you see on the left, this is a short video that I will be repeating a couple of times. On the left, you see Andreas Kostrau, who is a deaf sign language interpreter from Berlin. He is being recorded right now as we speak since May until October in Berlin for the first round of German sign language. And on the right, you see a motion-matched AI rendition of him. And the team of Synapse, the company we're working with, and I tell about them in a second, is working on making an AI model of Andreas himself. So in the end, we will have 2 German models. We will have Andreas as an avatar, and we will have the more female rendition on the right side, who is named Kim. So let me check here. I will play the video. So what you see is left is the video recording. On the right, you see the motion-matched AI rendition. And what you can pretty easily see is that they are close both what the movements of the body concerns and the mouth and eye movements. So that is just from the recordings that we are doing right now. So how does that work? Synapse, the UK company we're working with, the main input is text. You can use your own ASR with Whisper. We are mostly using DeepGram or something else to transform audio into text and then send text over to Synapse. You can also send directly live or video on demand, and then they, under the hood, transcribe using Speechmatics. So there are multiple ways how to achieve that. In the end, the input for their first models is text. The text then is transformed. And the output is either a separate sign language video that you can use on the second screen or as it's streamed on its own, or put it on a stage display. If you ever just don't think as a stream, think of a live presentation. There is a speaker on the stage, there's an audience in the room, you have a large display, and you show the live sign language interpretation on that display. Or you can get a burned-in picture-in-picture back so that you can have your original video and the sign language video. The latency roughly currently is 8 to 10 seconds. A human would do it in 3 to 4 seconds, so we're not there yet. But you can, of course, in cases where you don't have a live feedback audience, you can just delay the video until the sign language is built, and then you have it both perfectly synced. So when we were looking for a solution, there were a couple of requirements that we had. So the first is we understood that dealing with sign language interpreters is a difficult topic. So you have to understand how they work, what they are doing. So we needed somebody who had real experience with that. And so the good thing is with the company Synapse, the CEO, Sally Chalk, has been running one of the leading UK interpreter agencies for more than 20 years. So she really knows her way around working with sign language interpreters. We also knew from my own linguistic background that you have a huge research community around sign language. So we definitely wanted something that is grounded in academia. And the interesting thing with Synapse is it's originated at the University of Surrey. They have a Center for Vision, Speech, and Signal Processing. There are also two other universities that cooperated with Synapse. The University of Surrey also is a stakeholder in Synapse, and Synapse received UK research grants, I think 2 years ago, to build the first language model, which was the British Sign Language. Meanwhile, they have added the American Sign Language early this year, and we are now the sponsor and exclusive launch partner for the German Sign Language. And we aim for releasing the German Sign Language models later this year, perhaps in October, November. There will definitely be some news around IBC. And we also wanted that there is a community-first approach, because I don't speak sign language. We don't have any sign language interpreters or deaf people at the company. So we needed a solution that is really deep into support from the community. And the good thing is that Synapse is very deep into engaging with the different deaf organizations in the countries where they launch languages. And also 2 deaf organizations actually are shareholders of Synapse, the Royal Association of Deaf People. And the CEO, Mark Wheatley, is a person who is deaf and uses BSL as his native language. And the second is Action Deafness. So we have at least 2 organizations holding shares within Synapse, on top of what they do in terms of community engagement. So that is a lot and much more than what we see in other attempts that have tried this before. Something we're also interested in was the broadcast integration, which is good. Definitely making a lot of progress here, but that's GNL's home ground, so that is where we can wire it into whatever stack you have, using tools we use and love like Norsk from Ideas, and integrate it in other broadcast relevant setups here. So 3 check marks. That was the deal here. So we learned about them at IBC 2025, so not far ago. We signed a contract with them in January. Recording of the German Sign Language started in May. We are now halfway through the 10,000 gestures or glosses that we'll start with. And we hope to launch in November. So yeah, one nice IBC cycle that we have here. So the stages in which this works is, the first is a gloss is a written label for a single sign. So practically a set of movements of your eyes and mouth and body and arms is a gloss. And so the first is a translation from the written and spoken German to the sign language grammar and syntax. That needs a large data set. All these have to be recorded and then annotated and then to be translated. And the second is then the gloss recording that we have has to be translated into video. So they are recording everything in video in a training session. So all these glosses are recorded by native sign language interpreters. And once the first batch of 10,000 glosses is recorded, there is an ongoing relationship with the sign language interpreters so that they can add new vocabulary, because there with 10,000 you can cover a lot, but it's not everything you can do. And all the time there are new glosses that are being invented. I think 2 years ago in Germany there was a research fund that created 2,500 new glosses for natural sciences, so for mathematics and physics and chemistry. So there are new glosses. We also have a customer that is the Catholic Church of Germany, and whenever they have to do a sign language interpreting of a service in the church, they reach out to a 70-year-old nun in the small city of Paderborn, because she knows all these different difficult Catholic terms that you not usually use in your day-to-day communication. The capture rig has evolved from the first recordings that they did for the British Sign Language, where they started just with one HD camera. Now we are having 3 cameras from different angles. It's a 4K setup, and the schema looks like this here. So the person that is being recorded is in front of a green screen. Then we have cameras at different angles and distances. And that is being used for the 10,000 recordings for the beginning. This is a photo of the studio in Berlin. So the Synapse team came over from the UK with their setup here, with the cameras and with the recording equipment that they have come up with in cooperation with the universities. Also, the Synapse team speaks English. Andreas Kosthaus speaks German Sign Language, so there needed to be a double translation step. So translate the English into German, then have somebody translate the German into sign language so that they could communicate, and back. So this is a complicated process that you cannot easily copy at home with your vibe coding AI. So that recording is really a lot of work. What we did is we mined real German usage. So we looked into what the public broadcasting libraries are providing in terms of subtitles and what the German Bundestag, so the parliament, is providing. So that were a lot of subtitles from the last 6 months. We used them, normalized them. We did some linguistic tweaking on them so that we have separate single word lemmas like sehen, which is to see, multi-word expressions like Damen und Herren, ladies and gentlemen, compounds, which in German are wrote together, so Bundesregierung is the German government, or named entities like Berlin, cities, or names, or anything like that. And so what we then handed over is a list of 200,000 terms that they can choose from and see which ones they find gestures or glosses for. And these are the top 20 words we found in the last 6 months in the corpus that we analyzed. The API that they provide works in a way where you can then generate video on demand, so text in, then you get an MP4, HLS, or MOV file back. There is some silence where there is a person that is slightly moving but not doing something. There are some live integrations that are being worked on right now, where we have an integration with where they are using AWS Media Live under the hood. So it's RTMP and HLS in and RTMP and HLS out, working on SRT. There's also WebSocket API for low latency interactive text. And so I am now switching over to the live demo. So let me see that I can just stop it here. I put this here. So what we did at GNL, we took the API that we get from Synapse. I will just reset it in the hope that this live demo is actually working. So what we have here is 4 different interpreters. Ray and Mars are the ones for the British Sign Language. So one more female version, one more male version, and then gender neutral names. And then there is Jay and Max with the American Sign Language, which is different from the United Kingdom's one, the British Sign Language. And the British Sign Language is pretty similar to the Scottish Sign Language, but different from the from the Irish Sign Language. So it's a complicated, historically grown field. And then we have different aspect ratios, different qualities here. There's a low latency mode. And so what we do is usually we just type in a sentence like, my father is the King of England. I send it over here, and then the text is sent over to Synapse. They are producing the video. We are ingesting it here in the video playout. And usually, and it worked when I practice this before the call. You should see what's working. It's not working right now. So I don't know what happened here. Instead, I will go back to the presentation and show you how it works in the prepared demo. So let me play it here. We type in the sentence. That's the old rendition of the British Sign Language. It has been updated in the last couple of weeks. So in the demo, we usually show the new one. And then you see the rendition of the video coming back. And so this is an HLS stream, and we just ingest the videos that we generate. So now I'm showing J, the American Sign Language, which is in some areas similar. So the sign for Germans is the same, but the rest is different. And you get that video back. And you can then integrate that in more complex setups for live streaming and for on-demand streaming. But what you see is you type it in. We can also use the live to text-to-speech to text transcription and use that as an ingest. But what you can take away is text in, video out with sign language. So that's what I wanted to show you. And that ends my presentation. Thank you.
Impressive. Super impressive. First, questions from the audience. Oh, Oliver. Oh, you're very quickly. Go for it. Or you missed the button. That's the other question.
Yeah, I missed the button. The one question I ask is like, why do people want to see the sign language instead of like captions?
Okay, yeah, interesting question, and I had that myself for a very long time. The main issue is that for deaf people, sign language is their native language. The spoken and written language is a second language that they learn in a way like we learn a foreign language. So their children start with learning sign language, and then having to read is something completely different, which is a barrier. So that means if you only provide them with subtitles, you are not communicating with them in their native language. It's as if you say, okay, we just have one language in which we broadcast the streams, and you don't get any translations or any dubbing in other languages. So that's you're not targeting their mother language.
Thanks.
Great. Any other question for Alex? Go, Pablo.
Hey, Alex. Nice presentation. Is this gloss mid-text kind of language independent from the sign language? I mean, when you go to gloss, it's international, and then each sign language needs to translate that into different.
No, it's independent, and it's so if I would have to structure it, I would have to talk to a sign language linguist. But there are different historical lines in sign languages. And so the main differentiation that I know about, for instance, is the amount to which you use the mouth. So there are some historically grown sign languages that say, okay, you should more use the mouth, because at that time, the deaf people they tried to teach the deaf people to use their mouth like another people would, not like somebody who is not deaf would use. Other sign language schools said, no, this is not necessary. You don't need the mouth. This is a fully independent language. So, for instance, to my understanding, in Germany and the German-related sign languages, you use much more of the mouth than you use in other languages. So you can't just move it. And also, sometimes in some languages, the eye and eyebrow movements and the facial movements annotate what you do with the hands, and in many cases the glosses are completely different. So the same gloss for potato is different in the different languages. It's not always the same sign. There is something like an international sign language, but not many people are speaking it. It's like Esperanto. So no, you can't just record the glosses once and then use them for many languages. That's not how it works, unfortunately.
Great. I don't know if there is maybe we have time for the last question. Yeah, go Oliver for it. Or you're mute, sorry.
Wrong button again. Yeah, you mentioned you work with a linguist, or you didn't work with a linguist. Like how did you just purely rely on AI to build the translation from language to signs, or did you actually talk to a linguist or have some people that are?
Oh yeah. So Synapse has a whole research department with linguists, and so the whole topic is completely created and crafted and planned by linguists, and each recording and each process of turning the glosses into, or turning the sign language of a specific, so turning specific sign languages into grammar and into rules, how they are combined and how you move from text to glosses is completely supported by linguistic research.
And how do you do? Because you have multiple signs, like one word can be multiple signs. So is that also like something that is kind of guided by the language? So is the AI is purely able to learn about it by itself? Or?
No, it is. They are using a combination of, so when the text is being received, there is a combination of LLM work that translate that in multiple steps and takes into consideration linguistic rules that they have come up with for the specific languages.
And how do you provide these linguistic rules? Like, is just like a markdown file, or is more something?
No, so the text that you send over is just, in the most basic form, it's just an REST API where you send the text over, and the text is not structured in any way. It's not annotated in any way. It's just text, and then it's translated. They are doing an analysis of the text that you send to see if it's a question. So they're not looking only at the question mark. They're looking at is the way how the sentence was formed a question. They are doing a lot of research around the context that you provide. And that all influences how then the videos are selected that they have prepared before, and then they are merged live into the video that they send back.
Oh, okay. Very amazing. Thanks.
Amazing. Thank you, Alex. I think this is a very great example of how AI can be implemented in a video workflow, and at the end to really improve the quality and the experience of our customers, of people watching. And so I think this technology is amazing to enable more people to bring content to more people. And so thank you for your talk today. I think it's super great what you're doing.
Yeah,
Thank
good.
you. Great. Now we are moving with Nicolás Caballero. Are you over there? I don't see you on the screen, but yeah. Oh, great. What? Sorry?
Do you hear me correctly?
Yeah. Can you? Yes. Good there. Would you like to share screen? And well, the stage is yours, so go for it.
Okay. So, well, hi everyone. Today I will show you something we have been building for live operations teams, the Line Pattern Generation and Recognition System, or LPGRS. First of all, I would like to start with the problem. Imagine that you are a live operator having a live instance. You need to get data from different providers, triage, diagnose, try and solve the incident while every second is urgent and everyone is watching. And why it is hard? Because each tool speaks its own language. I mean, Conviva or Moocs data maybe could have the same metrics, but with different name, and you need to manual cross-reference between the different providers. And sometimes the diagnoses are trapped in a few heads. And seeing that something is wrong is easy. Explaining why fast and under pressure is the hard part. And that's the problem we are trying to solve with R2. And how we propose to solve it in two different parts and the other matters. First, we want to make everything speak one common language, and then we run an automated triage on top of it. And I will speak each one in the next sliders, starting with the adapters. The idea here is consolidate. Before anything intelligent can happen, your data has to live in one place and speak one language. I mean, instead of your team going out to every platform and manual reference between them, the LPGRS does for you. Every provider define an adapter, and that adapter has one shot, translate the provider data into a shared vocabulary. Then, to explain the automated triage, I want to talk about something completely different for like 30 seconds. And it's the emergency room case. Picture something you all know, a visit to the ER. A patient goes in with a symptom, say a fever. The doctor then takes their vitals and gather a bit more information. If those symptoms point to something familiar, the diagnosis is fast. I mean, the doctor knows the pattern, gives the treatment, and the patient goes home. But what if the symptoms don't match anything that the doctor knows? Well, then they call a specialist. The specialist looked at the same information and suggests a diagnosis based on his specialization. And why I'm telling you about a fever or emergency room? Well, because it's that exactly how the LPGRS system works. Imagine that the fever is an anomaly. Anomaly is something that your team decided in advance to count as not right. And when the system detects that there is an anomaly, it requests for more information or the vitals, and check it again every pattern that the system have defined. If a pattern match, like the doctor who knows the symptoms, we already have the diagnosis. And if not, then we call our specialist. In this case, is an agent or LLM, and we share the full context or all the metrics for each provider that we have defined. And if the LLM can, it give us a diagnosis and the next steps. And the best part here is that the new diagnoses are saved as a candidate pattern, and your team can review it, approve it, and next time the system will recognize it. And the idea here is to every new case makes the system smart. So maybe you're wondering if we can trust the specialist, because at 3 a.m. the worst things an LLM can hand you is a confident wrong answer. And because of that, we want to use it as a last resource. And we have 3 rules here to avoid hallucinations and generate the best patterns that we can. The first one is the evidence-based. The LLM reasons only over observed metrics. It is allowed to say it's not enough to generate a diagnosis instead of inventing a cause. It don't have enough information. And finally, a human stay in the loop. The AI proposes, the expert validates, and approves what becomes a pattern. So next, let me share with you how this works under the hood. The system is based on publisher-subscriber pattern, and, well, of course, decoupling the responsibilities in different services like providers, detection, diagnosis, and others. The first step in the system is the ingestion. Every provider is requested by his adapter, which translates the provider raw model data into normalized and shared vocabulary, and then published in the event bus. The next step is the detection. Multiple rules that your team set up watch the metrics of that stream, and when something stays over some limit long enough for some time, it's fired an anomaly. The anomaly is published in the event bus too, and then we go to the step 3, which is the diagnosis. The system there builds the anomaly profile and check it again the patterns we already known or defined. And if nothing much, then we will call to the specialist or the LLM. In this case, we just use Anthropic, but there is a generic interface when you can put another different LLMs or agents. And finally, the notification step, we post messages. In our case, we use Slack for testing purposes, but it posts when anomaly is detected, when a diagnosis occurs, and when the resolution is there. And with all that's in mind, let me show how this works. I recorded a demo to explain it, so I will start here. Well, this is the initial view of our system, the event viewer. Here we can see all the events that are being sent to the event bus. We can open each event to see its JSON payload. We also can filter the different metrics for a specific stream or for a specific adapter. Then we have all the configurations. And a stream is a specific entity that groups all the different contents IDs from each provider. Sorry. In other words, you can monitor one stream across different providers, and here is where you merge them. Then the adapters, and an adapter is the entity that defines what we want to pull from a specific provider. Here we define the general metrics and the specific metrics, because you can want to get some metrics from one provider and another one from other provider. The specific metrics are metrics grouped by specific dimensions. These are the ones we will pull in the diagnosis service to match the pattern later. Sorry. Well, the vocabulary is is where we define the shared vocabulary. Right now, we are focusing on quality of experience metrics, but our idea is to have different families of metrics, such as CDN, device, or others. Then we have the rules. Here we define the symptoms. This will be triggered anomaly. This is how we define what counts as not right. And finally, the patterns. There are the known cause. A pattern define which rule make it selectable, along with the evidence signature, where we use the dimension I mentioned before. This maps to a root cause with a suggested action. And well, these patterns can be born either from handcrafting or from a promotion. In this case, we have already defined this one for the demo purposes. Well, the promotion tab, we will talk about it later. And well, service status is just a view to see how the different services are about health. Great. Well, this for this demo, this demo doesn't hit to a real provider because we don't want to run a live demo against production data. So we create a mock provider that mock telemetry for this demo. And this page, this small demo control, lets me trigger some specific scenarios on demand. For example, inject an anomaly, drive a known pattern, or force a new case that escalates to the LLM. So in this case, we will click on Akamai CDN failure, and we will trigger this issue, which is related with Akamai playback failures and buffering timeout. And I will move forward to avoid the time. So here we got the anomaly and then the diagnosis, and you can see the diagnosis was matched with a specific pattern, and it's come from the layer 2. And if I move a bit more on the video, well, we got the notification on Slack. As you can see, we get the anomaly detection and the diagnosis, and comes from the layer 2. So I will continue to the unknown issue, and okay, here. So this one is related to video start failures on Samsung TVs in specific. You can see the dimensions here on the right side. Forward here. Okay, we got the new anomaly, and then we will get a response from the LLM. Here it is. As you can see here, it's coming from the model Cloud Sonnet 5, and well, it was produced for LLM, and is saying which the LLM thinks is the cause and a suggested action. With all this, we will receive we will receive the diagnosis, of course, and a new event, which is the promotion proposed. This one we can see here in this tab, the promotions, and you can see here, we can see the explanation why this is happening, and the suggest pattern and the suggest action. And of course, you can change it if you don't, and you as an operator are not agree with this, you can change the suggest action or change the proposal pattern. But the idea of the system is this one. So I will continue with the slides, and to wrap up before we close, for a problem maybe the live operation teams has, LPGRS brings one solution with concrete wins. It saves times because known costs are resolved instantly. It saves resources because everyone speaks one language, and the LLM is used only when and where it adds value. It scales because add a new provider, a new notification system, or a new LLM or agent is just generates another component and combined with the rest of them, because we have a lot of common service, it can be reused, and it keeps quality high because a human stay in the loop, the AI proposes, and the expert validates and promotes. And well, thank you very much for your attention. If you have any question, I open to answer. That's it.
Amazing. Thank you. Great. Let's see. We have some questions from the audience, and don't be shy. I may have a question for you. So as I understand, it's like these different levels that you said. Like the first level, you are getting all the
That-
metrics and doing some triage, and I think it's a deterministic thing. So you're not using the LLM in the first stages. You're seeing if you already have some patterns.
Yeah, exactly.
So
Go ahead.
yeah. So my question is, when you try this on production, so I guess there are a lot of inputs from systems. How hard it is to configure all the rules you already know, or from experience? It's like live teams already have some playbooks. They know things that happen. So how hard it is to configure all these things in what you just show?
Yeah, of course. Well, as I showed recently, you can use the UI to set your rules or your pattern that you have already defined in your playbooks. And the idea is of course, the first time you get this system, you need to spare some time to put all your playbook rules into the system, because the idea is to have to use the LLM the minimum times, so you can save costs there and also be more deterministic on the issues that you catch.
Got it. And have you tried just to send logs to the LLM and see what happened?
No.
Does it work, or it's like
No, I don't try. I just define the rules and just use LLM
great?
when should be used.
It will be fun to see what try to invent. I'll hallucinate.
Yeah, I don't know. Maybe we can try later.
Any other question from the audience? Great. Thanks, Nico. And thank you for the presentation. I think it's very cool to see using people who is trying to put this into production and see how really, it's not just throw all the information to an LLM. So do what we know very well, the deterministic part, and try to figure out new issues and new problems with these new tools. So I think I like that approach in particular. Great. And now moving forward, if you were there, Emil, I think you are next in line.
Yep.
So let's go with your presentation. Thank you.
Thank you, Nico. Let me share. All right. Hi, everyone. Thanks for staying here. Today, I want to tell you a very specific story about how we are automating quality control for video highlights at a scale. The title is The Whole Talk in One Line. Every clip that airs gets one of these three verdicts: pass, fail, or ask a human. The interesting part is deciding which of the three and who answers it. If it is a code, a model, or a person. So imagine that a broadcaster is publishing out highlights, specifically sport highlights, those and hundreds of clips, very fast and during a weekend. And before any clips airs, someone has to sign off on three things: that it's technically clean, capture the right moment, and it follows the brand spec. For example, if it has the logo, the scoreboard, the intro, etc. Today, that's a human watching every clip end to end, and that person, of course, is excellent at it. But this person couldn't be the bottleneck between both happen and the clip is live. So the mandate sounds very simple. How automate the quality gate, and this talk is about that, why this simple was a trap. So the quick answer is, okay, you can throw it to an AI and there's a trap. The quality isn't only one thing, it's like three very different kinds of check. We have, for example, mechanical rules that you can measure from the signal. For example, the duration, if there are black frames, silence, these kind of things. Then you have things that you have to look at the frame for. Is the logo there? Is really a goal or a miss that some of the generator made a mistake with that? And finally, the judgment calls that are pure taste, like this is the best 90 seconds, or what are the root causes that the errors are detected in the other phases. So point one to at all three, and you lose both ways. For example, too little AI and the percent of stuff say through, but for example, too much AI and you burn cost, latency, and trust checking things that could answer with FF Pro or FFmpeg line. So the hard question here is, so the question is like AI or not, like it's more about which tool or for which check. So the core of what we build, and honestly, like the core of this talk is like this route and decision. For every single check, we ask what the most cost-effective tool that can answer this correctly. So remember, like cost-effective and correct, not the fanciest. So let me show you in this diagram. So for every check, we have two questions. The first one, can I measure this straight from the sign and from the video? If yes, that is code, that is FFmpeg, FF Pro, these kind of tools, like full deterministic and done. If no, the other question is, can a model see it's reliably enough to trust? If yes, like computer vision or vision language model, but only by exception, not by default. And critically, has to bring like the evidence, not just the yes or not. If even a model can't be trusted with it because it's generally subjective, then and only then does it go to a human. So the key mental shift is that this classification, you make it per check upfront, not something that you decide per clip at runtime. So a single clip carries dozens of check, and each one is typed as deterministic or semantic in the spec. Honestly, most of them are deterministic, for example, for playback, for decodability. And there are a few that more editorial or more detecting what is in the scene are that we call it the semantics. So we don't have of like one to each other. So we run independently because we need to check both type of spec in this system. So I will illustrate like in each lane. So the first lane, the one that I said, is full deterministic. We don't need like a model. In these cases, enters like duration, checking duration, as filtered black frame silence, a lot of things that they are very cost effective and very fast. Of course, they are reproducible. Like in the same input, we will have the same variety forever. And they are very auditable. Like we don't have any hallucination here. The second one is more, when we need more perception, like we need to observe the frame or see what is happening there. Like for example, to check the logo present that is currently placed, or checking the scoreboard. And here, the whole thing that we can use an LLM or a vision language model. Of course, it will cost money if we are paying as a service, and it will have more latency than to run in a more deterministic tool. Well, of course, it's non-deterministic, so maybe the same frame could have different answers in the time. But the idea is that we have this kind of rule with a lot of evidence, like the full evidence, the moment, the measurement, a frame, not just if that is good or not. Well, the lane 3 is the human. So some checks, of course, are pure taste, like the best 90 seconds or the emotional arc of the clip. And we are deliberating, not automating them. A confident round answer on taste is worse than none. We don't allow to decide which clip a person sees. That's a direction, not chip. So today is very simple and honest. Like when the tool can back a call with evidence, it flags it for review instead of guessing. The point is, isn't a feature, it's a restraint, like knowing what not to automate is part of the design itself. So I say too much, so I will show you a little bit about how it looks like. So for example, here we have like the catalog that we can filter for the station that they are. Now we are going to a clip that is passing the rules in a second. Here we are. So this clip is passing the whole suite, but there are some warnings that it goes that it shows there, like commentary is cut off in the mid phrase, and also the clip is missing like an intro, title card, or graphics that are more like editorial stuff. But they are declared as warnings, so it's still safe to publish. And also there are some helps that indicates the go moments, just to check it if you are good with that. Also, you have the full evidence of all the tests and all the check that we are doing and we are performing in that. Here, the commentary break is like a full automated, sorry, not automated, like full semantic check. So here we have the reasoning of the LLM of why it is thinking that the commentary is like they have a cutoff. And also we have the full goal detections in the clip. Back to the catalog, this is like another clip of the same match that they have like some video and audio feed loss. So here the editor's note is like a full summary with all the check, and also is giving like a hypothesis of what is happening. For example, here it detects black frames, video frozen, and audio drop. So the three of them are for the same reason. Maybe it's not feed loss, but maybe something more happened, but it goes is give you like a clue of what is happening. And again, also the same warnings of the clip. And the last part that I want to show is like also you can configure it like the rules that you want to follow. For example, depending the leagues, the sport, whatever. For example, here we have like the logo presence that the UI helps you like to configure it when you expect the logo to be there. And also you can configure if this rule is blocker or just a warning. That's it for the demo. Let me go back to the slides. So here it comes, the lessons. First one, start with the deterministic, like sit down and decompose like the quality into the checks before you touch any model. Nobody better without evidence. This is the single most important one. Every AI answer must come back with a time code and measurement, and it's made the system auditable and lets a human decide in seconds without watching the whole clip. And this is different between an explainable tool and a magic box that nobody trusts. The confidence not binary. Don't force a model to say yes or no. Let it be unsure and route the unsure cases to a person. That's the grain zone lane that I explained earlier. Build the labeled corpus early, like a library of known good and no bad clips. Of course, you can tune thresholds or measures regression without it. Put models both behind adapters. We all know that models change every month, every day, every week. So price, quality, and who is even available needs to be like exchangeable. And like the meta lesson under all of them is designed for trust, and every single decision either earns or spends operator confidence. And that's the budget that actually matters. So if you take one thing home, is this, like, stop asking, can AI do this? Like, the answer is almost always technically yes. And it's the wrong question. It leads like straight into our tooling. Asking instead, like, what's the most cost-effective tool that's actually right for this check? This is sometimes that, for example, an FF-proof line could solve. Sometimes a vision model. Sometimes a human being like checking. All three are good answers, and a system use all of them. That's it. Thank you. Have any comments?
Amazing. Thank you, Emil. And go for it, Alex.
Yeah, hi. Thank you for the presentation. Very, very impressive and good approach here. So the decision boils down to what is the most effective tool to solve a task. And so how do you did you at some point quantify that? So is there a deterministic process that can take it? This is the task. This is the list of tools that I have. How do you derive to the decision which is the best one? Is this just experience and you say, okay, if I'm wanting to do this, I take this tool, or is there a measurement and is each task measured and is there a benchmark behind it, behind the decision?
It's a good question. Right now, we are like running the spec that I show, like most of the check that are related to like playability or decodability of the video are of course deterministic. But for example, the logo presence, that could a model, of course, check for that. Right now we are using, like, for example, OpenCV, like it's not AI, it's computer vision, so it's not so non-deterministic, but it's not completely deterministic. So right now we are like checking all the rules that we have there, but also we are start like researching what happens if we send the whole clips to an AI. Like it would be more effective or not. Like we are still like tuning if we want to be more AR dependent or not.
Yeah. Okay. Thank you, and totally understandable. So the perspective where I'm coming from is we are currently working on getting certified for EMAS and ISO 14001, which is the environmental qualification, so that we save energy where possible, and that boils down in the end so that we attach the energy consumption per function that we do. So we have a range of things that could, for instance, analyze a video for, is it compliant? So the things that you say are deterministically provable. Any tools that can do that. So going through these tools, the usual suspects, and then making a calculation of which of them is the most efficient one, uses the least resources, so that they are benchmarked against each other, and that you say, okay, I would like to use this one, but there is a cheaper one that also does the job, following your philosophy of what does the job, what's the easiest and leanest tool to find the job, so that these decisions have a real price tag, so to say, that you can then pull from.
Yeah.
That's a very interesting angle, to be honest. Great. Thank you, Alex, for your question. Lautaro, I think your hands up.
Hi, nice presentation. I have a question regarding the process with the LLM. I understand that when the clip has a failure, it posts the evidence, so it's easy to check that effectively is a fail. My question is, when it doesn't detect an issue, do you think that is always needed to check it for a human, like to check if it's not a fake positive?
Okay. Right now, how it works is like the deterministic rules are more like blocker or not. Like if one deterministic rule fails, it's kind of a blocker to publish, because we have more confidence for them. The ones that are coming from an LLM are not blocking, but they are most suspected for review. So they are marked for review. Then someone is going to review manually, but of course with the whole evidence of the all of the rules, like they have their own data.
Okay, thank you.
Great. Thank you, everyone. We are run out of time. It's just a few minutes past. So thank you, everyone who's still here. It was a challenge to have three meetings today. And again, thank you, Alex. Thank you, Nico. Thank you, Emil. I think it was great to see how AI can be inserted in our video pipelines. And I think this is a great evolution of everything we are seeing right now, and everything is happening is very, very, super fast and evolving in an amazing way that is super exciting. So again, thank you everyone for being here, and hope to see you soon in the next Montevideo Tech Meetup. Thank you.
Thank you as well. Bye-bye.
Bye-bye.
Thank you.
Thank you.
Bye-bye.
Thank you.